Hello everyone, I'm Vaibhav Srivastav, Product Manager with Azure Stream Analytics team here at Microsoft. Today I want to talk about Stream Analytics Kafka input and output connector, which will be generally available post-Ignite 2024. Stream Analytics has now made it so easy and intuitive for our customers to ingest and process the data from any Apache Kafka cluster into Azure. It's a low-code solution which is fully managed by Microsoft. Let's take a quick sneak peek of the agenda for today's video. Let's begin with an overview of Stream Analytics Kafka connectors. The ability to ingest Kafka events from anywhere, process them using ASA, and then output them to any number of Azure services as well as to Kafka cluster anywhere has immense benefit to our customers. It results in a simpler end-to-end design and potentially lower cost. Users can connect to any Kafka cluster with a public endpoint as well as to any cluster inside a VNet. Now there is no need to use workarounds such as Mirror Maker with Event Hubs or Kafka extension with Azure Functions to process data in Kafka with Azure Stream Analytics. Before we jump into the demo, let's take a scenario of calculating toll booth efficiency as an example. A toll station is a common phenomena. You encounter them on many expressway, bridges, etc. This solution works with two streams of data. Sensors installed at the entrance that are producing entry stream by writing events to a topic in a Kafka cluster. And the sensors at the exit are producing exit streams by writing those events to another topic in a Kafka cluster. We want to calculate the total time taken by the car between the entry and the exit location. To achieve this, we will set up an Azure Stream Analytics job to report total time taken by each car. Stream Analytics will send this process result to another Kafka topic for further downstream processing. Let's begin our demo. In this demo, we will be following these steps one by one. Let's take a look at our input event source. I'm using Confluent Cloud for Apache Kafka. Here, my entry stream topic is receiving all the entry events when the car enters the toll booth. Similar to this, I have an exit stream, which is capturing all the events for the cars as they're exiting the toll booth. Now let's jump into the Azure portal and see how we can ingest and process these events in a Stream Analytics job. Once you have created a Stream Analytics job in Azure portal, you'll first come to an overview page. From here, we will navigate to the job topology and select input. Then, from the input dropdown, we will select Kafka. Now over here, it provides us the configuration for our Kafka cluster for ASA to connect and authenticate. Server address is a list of host port pairs to establish the connection to the Kafka cluster. Kafka topic is a named order partition stream of data that allows for the publish, subscribe, and event-driven processing of messages. Next, you will decide or select what security protocol you want to use and how you want to connect your Kafka cluster. Stream Analytics supports MTLS, SASL, SSL, SASL, plain text, or no authentication. Confluent Cloud also allows you to connect with Apache Kafka using API key configuration. Since we are working with Confluent Cloud in this demo, we will select this. Towards the end, we will select the event serialization format, which in our case is JSON. But there are many other event serialization formats that are available for you to choose from. Now, similar to input, next we will configure our ASA job output. For this, under job topology, we will select outputs and click on the add output dropdown. And as you can see, there are a lot of choices to select. For this demo, we will select Kafka. A similar form will be presented as we have seen for the input, where we have to provide our connection configuration. Once you have filled out your connection configuration for the output, you can test the connection whether ASA job can successfully connect to the topic of that Kafka cluster. Next, let's jump into the query editor. Here I have my input and output streams already listed. I can click on input preview to see the structure of my incoming streams. For me, the entry stream structure looks like this, and the exit stream structure looks like this. Now I will define my data processing logic. I will add my data processing logic in the query editor. And I will test my query. Once it is successfully tested, I can go ahead and start my job. Now my job is successfully running. Let's validate the output. As you can see, my output is connecting to this particular Kafka cluster on this topic. As you can see, my ASA job is writing the output events to this particular topic on this cluster. Let's look at the topic and see what kind of results ASA job is producing. Here in Confluent Apache Kafka. Now my ASA job has successfully started. Let's validate the output. As you can see, I have configured my output on with this Kafka cluster address, and the topic name that I have selected is tollbooth total time. Let's go jump into the Confluent Cloud and validate the output over there. Here in Confluent, I have selected the tollbooth total time topic, and these are the outputs that Azure Stream Analytics job is constantly producing. We can validate the structure that matches with our processing logic, and it is now calculating the total duration in minutes for every car that's entering and exiting the toll booths. If you're using other security protocols to connect to your Kafka cluster, like SASL SSL or MTLS, please refer to our documentation to learn more about how to configure that in Azure Stream Analytics. One challenge of using Kafka is securely giving access to external resources. You can solve this problem by using VNet. Configuring your Azure Stream Analytics job to use virtual network allows you to securely connect to your Kafka cluster inside a virtual network or behind a firewall. In order for Azure Stream Analytics job to securely connect to a Kafka cluster behind a virtual network, there are few extra configurations that we need to set up in our Azure Stream Analytics job. Let's jump to the Azure portal and take a look at those configurations. Here in Azure portal, under your Stream Analytics job, let's navigate to the settings section. First, let's make sure that we have added a general purpose V2 storage account to our Azure Stream Analytics job, as it is required for the VNet injected ASA jobs. After that, let's go to the networking section. Here we will be selecting the virtual network, which is the same virtual network where your Kafka cluster is running. And then we will be configuring a subnet under the same virtual network. You will first have to create a subnet within the same virtual network where your Kafka cluster is running. Under the subnet configuration, please make sure to add the network gateway, network security group. And under subnet delegation, delegate subnet to a service, you have selected Azure Stream Analytics. Once this configuration is complete, now back into your Azure Stream Analytics job, we will select the networking. Click on run this job in a virtual network. Now we will select the same subnet that we have just created and click save. And that's it. These are the only extra configurations that you need for you to successfully connect your Azure Stream Analytics job to a Kafka cluster secured with a virtual network. Let's quickly test out this configuration. And look at that. Our Stream Analytics job is successfully able to connect to the Kafka cluster now. I hope you found the video useful. If you still have any follow-up questions, feel free to reach out to us at askasa@microsoft.com. Please add tag Kafka to your request for faster response. Thanks for watching.